All right, let's get started. Thank you for joining. My name is Khurshid Hassan, and today I will be conducting a very hands-on webinar on the the new world of AI FinOps and how you can play in it and benefit through cost optimization. I'm sharing my screen in a moment, and what I want this webinar is to be super interactive. What we will do is we will actually also allow you to log into the dashboard that we have and play with it. So that will give you a much more tangible feeling of how this whole thing works. So I presume this PowerPoint or deck is visible. If not, please put a message in the chat. It's all good. Thank you. All right. So how to cut your LLM API bills by 75 to 90% and without any code changes. I mean, it's a little bit cheating here. There's a slight code change, but that is like next, it's a noise level. Anybody can do it in like 30 seconds. So let's keep going on. We have a range of topics here, and I will kind of paste my slides in a way to communicate. And please put any questions on the chat window, and I'm monitoring the chat window here, and I will answer those. Myself, a quick thing. I actually used to work at AWS and Western Digital, different corporations before, and since the last 3 years, nearly 3 years, I'm running Cloud IDR. We also call it Cloud IDR. We were recently part of Skydeck Accelerator, and our flagship product is LLM Ops, which allows cost optimization and visibility and budget controls for the token world. So what is going on? I mean, it just seems so far away, but the ChatGPT got launched a little over 3 years ago, and the revenue numbers, which I believe most of you know, are remarkable. I mean, this thing has taken off like nothing else in my experience in the technology world. Within 3 years, the business is between the two of them is already at an ARR of 50 billion plus. And I think if you add Gemini and you add other open source models, it will be much, much greater. I mean, this is incredible. So now the next thing is if you want to look at AI FinOps, which is financial operations, how you optimize the spend, you have to think about tokens. Tokens is the currency, tokens is the context. And typically the way I simplify the thinking is one word is basically one token, or let's call it 4 or 5 characters, right? So one word is one token, simple. And typically when you use these large language models, you are sending a question that is an input set of tokens. The model gives you a response back. There is an output part to it. And the total cost is input plus output, right? And then there's a thinking part as well for reasoning models. You can just lump it into the whole output thing. With this notion, we're going to move on. And we want to kind of illustrate the variance in the pricing. What you're seeing this table is a handpicked a few models. At the top is the latest and greatest GPT 5.5 Pro, which came out last month. And if you can see, the output token cost per million tokens, which means per million word of output coming back to you, is $180. You can see also the variance between input and output tokens. And that's on purpose because they want you to come in and ask questions, right? So input is lower cost, but if you put in PDFs, that increases the size of the input tokens. And output is where they actually charge a lot more. And you can see the delta, which is like 4x to 6x here, input to output tokens. The industry has standardized in the way of talking about costing per million token. Just like the industry in the cloud world has standardized across virtual CPU. How much do you pay per minute for a virtual CPU? So there is a range here, which basically means different models can actually effectively work on different tasks or different workloads. And there's this 450, just between the two of the output tokens here, there's a 450x price differential. So that means there's an opportunity, or it means there's a wastage that is happening. And this talk today is how you can control that. How, first of all, can you look at it, control it, and then optimize it? All right. So I call it AI FinOps, and there are some other companies out there who have also started branding it this way. AI FinOps is very different than Cloud FinOps. I have a blog about that. You can take a look at it. It's a blog on our website, and it kind of differentiates it. Under the cover, AI FinOps is real-time tracking, real-time response, and the data models are completely different. So you cannot force fit one on the other. Now, there are three pillars of AI FinOps. I call them visibility, control and governance, and optimization. Kind of similar to what we have in Cloud FinOps also, but the approach is very different. I'm going to illustrate that. So, what is this first foundational pillar? It is visibility, right? But visibility about what? It is the visibility about your usage pattern or your usage. And what we do is that we want to track the number of tokens that you have used, as you can see on the uh, image here, the cost associated with those tokens, and more importantly, each of the line here is a request. It is like typing on a console for ChatGPT or Claude and saying, "Hey, give me a summary of the recent events or the history of United States of America." So that's a request going in. We call that request tracking. And then for visibility, what we recommend is that you tag every request. That is super important because without that, you cannot create a understanding of how to control and optimize down the road. So the first step is measurability, measure it through visibility. The second pillar of the whole thing is governance and control. Who can use tokens? Those are like API keys are allocated usually. But the more important point in the agentic world is you have these agents which are sort of autonomous. They're making decisions autonomously. It's not like humans sitting and asking questions and saying, "Oh my gosh, my budget is over. I should pause." But it's not like them. These are kind of automatically running, and they can be running in a wild mode, open loop. Uh, so you want to sort of put some level of control or budget spend limits on them. And in our tool, what we do is that we actually do allow you to selectively enable, enforce budget ceilings on a monthly basis. And this can be done in many different ways by different people. What it allows is that you don't get surprises at the end of the month, and the consumption can be very, very fast. Even though it seems like $5, $10, $20 per million tokens, I've seen companies who have gone from basically a few $100s a month to $10,000, $15,000 a month, as they tend to replace their own GPU hostings and kind of go towards the march towards the open source models. The third pillar is once you have the visibility, can you optimize the spend amount? Not only control it, but optimize it, which means bring it down. And we have to kind of go back and look at this table to really get an intuitive sense that yes, there is an opportunity. Why is that? Because if you have worked on any of these chat GPT like interfaces, you quickly realize you can select a model, right? Same thing happens when you are operating on an API side of the world. One thing that I forgot to mention is that this topic is for people who are integrating large language model through the API calls. So they are actually sending the request through programmatically. And in that case, they have to select a model and they will go and usually pick the best model, which will they baseline it to get the most consistent result, which is okay. Like they may pick GPT 5.5, which is okay when you're doing some complex reasoning or strategic thinking and asking a lot of questions around that. But if you apply the same model for summarization, you're just basically overkilling. You're paying 30, 40 times more, right? So it doesn't make sense, but a programmer doesn't have the leverage, liberty to understand every single thing. It's all programmatic, right? So what it means is that you can build some intelligence in the routing layer where you can look at the prompt. Prompt is the question that you're sending to the model and kind of route it to the cheapest model for that prompt, assuming you maintain the quality. So you have to maintain the quality. It cannot be a blind routing. Otherwise, there will be hallucinations and bad data coming back. You don't want that. The other thing, so that's a technique that we at Cloud IDR it deploys with LLM ops, and it is all real time within milliseconds. The decisions are being made. The second thing is what companies do is caching. Caching is a very common understanding. It is something which has been called again. You just cache the results ahead of time because somebody else has called it, and you respond back without going to the large language model provider or to the GPU, right? So that obviously you can save money because there are basically no input tokens and no output tokens being processed for it. And the third thing is prompt caching, which is more like the providers do, Anthropics and the people who actually run the models, they do that. And that is a way to put less of the tokens into the GPU for processing. A prompt caching is something like, "Hey, you are a SEO expert, and you are going to write me a blog." So that thing is a prompt starting point, right? You can just call and you can just don't have to repeat it every time you have to say the same thing. So those are techniques, but what I'm showing here in this image is different agents where they are sending different amount of requests. How many of those requests are optimized? 21,000 in case of a monitoring agent. What would have been the original cost if they had gone and used that premium model versus by routing what they actually paid and how much the savings would be. And we have published some benchmark results where the savings actually can be 90%, 77%, depending on the prompt and the use case. All right, so this is a very quick overview of the differences between Cloud FinOps and AI FinOps. I am going to put your focus into the bottom row data models, very different data model. And I'm going to kind of tell you that reaction time, the third from the bottom, has to be really fast in the AI FinOps world, right? And I'm going to move on with that after that. So this is a result of two different studies that we did. This one is on the healthcare side, and you can see in red everything is normalized to $100,000 spend. And there are two different sets of data here. The first two columns are for summarization, and the last two columns are for triaging in the medical field. And if you can see, if we do model routing, the first thing which I mentioned earlier in the optimization, you can very substantially save money here. I mean, in one case, it's close to 100%. Again, we're taking a baseline model, which is Gemini 3.1 Pro, and these can be routed to much cheaper models on few cents, tens of cents for a million routes. I'm going to pause here. Any question? Please type it on the chat. Okay, none. So let's move on. Uh, this is another benchmark on a financial bunch of financial data set. Okay, so the question is how do you semantic routing? Let's go back here. In the semantic routing, what happens is the request will come to a let's call that a dash, I shouldn't say a dashboard, a web server, or application server. That application server would keep a track of the previous request that has happened, and it would have been cached with input and output. So it will first match to see, look, this, I mean, I'll take a very simple example. Give me a history of United States of America, right? I'm just taking a simple one example here. So that somebody has asked a similar question before. So it will look into match with whether that has been asked and will answer right from that application server. This can be done by provider. It can be done by a third-party company. Anybody can do that, assuming they are in front of it, right? Like an AI FinOps company like us. So the advantage is because you route the traffic from before hitting the people who are charging you, you're saving money with that. Now, this can also be used by folks who are running their own GPUs and running their own models because they don't have to hit the GPUs. The moment you hit the GPUs, you have to spend more GPUs and the cost goes up. Did that answer the question? All right. So coming back to financial benchmark, these were four different benchmarks, which included looking at SEC filing reports, asking questions on headlines, sentiment analysis on what the stocks looks like or the company look like. And there's a little bit more complexity in this benchmark. Again, we kind of a baseline everything to $100,000 spend, and we use Anthropic's Opus as a baseline model because of quality. Okay, there's another question about how do we decide about the minimum capable model. All right, I'm going to sort of do a live demo later in the just after a few slides, and then we will talk through that. How do we do it? How do we ourselves do it, or how anybody can do it? So in this particular slide, what we do is that we showed that in our technology we can route to the same provider because assuming you don't want to move from OpenAI, just want to route within OpenAI. There's dozens of models there, or within Anthropic. And if you do that, in this particular case, routing within the Anthropic, how much can you save? And then we also, which we call flexible routing, we also sort of host open source models as the mid-tier models, not the cheapest one. And if we route to them, we can actually save a little bit more here, but not in this particular case. So it can really vary. Some of the decision that we can make in the routing may not be optimal as well. As you can see in this last case, if we routed to our model and wasn't that effective, but in other cases it was more effective, right? So there can be a slight variation. But in nutshell, if you use optimization, you will get benefits. And this is all model routing benefits. We're not talking about semantic or prompt caching, purely model routing saving you money. All right, so now this becomes an interesting part. What we are going to do is we are going to actually do a hands-on lab. And what I will suggest is I'm going to put this thing in the chat window. What I will suggest is to sign up here. It will be really fun. Once you have signed up, let me know. I'm going to sign in myself. Uh, so we missed a few things in recording. That's all right. I'm going to go find the key here. All right, so I have the key. I'm going to put the key here. And what I'm going to do here is this is Cloud Gemini, and I'm going to ask a question, decline a meeting. It's a very simple question, right? I can move the number of tokens. I can put some thinking tokens, and I will run an eval. So you see the baseline model. and you see the model being routed by us, right? Now, in this case, I will go, you will see a selection multi-providers. So in this case, our routing engine had two different options. We have either it routes within the same provider, or it can route to the same provider or to the open source model that we are providing as well as a managed inferencing. In this case, the routing engine decided that is going to route from the baseline Pro preview to Gemini 2.5 flashlight, which is a much cheaper model, flashlight, 40 cents, right? 40 cents versus, let's say, $12 output, 30x cheaper. And this is how output looks like, right? So in this particular case, from a manual point of view, you can see that screen, correct? Or no?
Yes, I can see it.
Okay. All right. Super. 1 second. The share is working. Is this something fancy is going here? All right. So there are two ways to do this model routing comparison. You can do manually, and many times people will run dozens and dozens and dozens of different prompts and say, okay, I feel confident with the routing engine. Now, what we do is we show you the thinking tokens, the input output token, the cost here versus the cost here. You see the delta, even though this is there are a little bit more prompts, output prompts here. And then we have a judge, right? And judge is really important. Now, in this particular case, we also allow the judge to be selected. In case we selected this judge, but we could have gone and picked the best model for the judge, right? Pro view, uh, which is out there. And the judge is saying that it judges on multiple criteria. It gives a baseline model a score of 7 out of 10. This is a baseline expensive model. The routed model, which is Gemini 2.5 flashlight, gives a score of 7.8. So there is a metric that has been established. The evaluator is an LLM in this case, yes. And you can select the evaluator. So the way to do that is two things. Manual. So because only the person who is subject matter expert will really have the best experience, not a company like who is the middle like us, right? So they can use this interface to evaluate whether the routing engine makes sense or not, and then turn it on and off. It's up to them. And what type of routing they have to do. And I'm going to show you that we have much more sophistication than that. So, and then they can sort of also use this judge evaluator to say, look, scoring, because it makes it easy. And we store up to 20 different evaluation, and they can go and look at it and compare it for ease of use. Any question here? I think, look, if you want to do it manually, it's one of our customers that actually started with the highest model, then they went to a mid-sized model, then they went to up and down. It kind of can vary, right? So there is no good answer at this time. But what we have done is to find a intersection of space where we route conservatively. And I'm going to show that in a second here. This is a optimizer setting for us. This is what we selected when we were evaluating, and our routing engine selected the model within the Gemini family. It did not came to select one of the open source models that we host. It selected a Gemini family model because it thought that was good enough for the job. And we saw Judge also giving a good answer, which is totally independent than us, right? That has nothing to do with our routing. The judge was actually, we sent the query to a judge, and the judge came back with an answer with both of them. So LLM judge kind of agreed with the routing strategy. That's the short answer here. Now we could have just routed within the any of the provider family, or we selected this one. We currently use this algorithm, which is a custom proprietary algorithm. As I said, it looks at dozens of attributes, it scores on a 400-point basis, and decides whether to route which model to route into, right? And right now we are working on some adaptive ML thing which we cannot talk about on routing engine. Now, we also have very certain industry. Yes, it's a proprietary algorithm. That's a sort of one of the secret sauces. So we also have developed some plugins for different industries. And if you turn on these plugins, if you're in that domain, it actually makes even smarter decisions for the routing, right? So, and in multiple ways, actually, sometimes the routing engine will be very conservative and it will not route where it should route. So with these sort of a domain plugins, it will, if we force it to route, we try that to be less conservative because we have the confidence that we are doing the right things. Um, and then there are different things, right? If the model is failing, it's not available, or you can fall back to the original model. Do you want to tag? Do you want to optimize everything, only the things that have been tagged or labeled? There's also a protection which we recently found issues that the models doing the evaluations we are doing for a customer, that the models typically have cutoff dates, which everybody know. And we kind of added a protection because the what we found is the original model was hallucinating, the routed model was hallucinating, and the judge was also hallucinating. So there are corner cases there as well. Um, Anyway, so this is a playground. This is a really fun thing to do. You can put, as I said, keys here, and this is without the evaluation. Just play with the product, do this tagging, uh, give some questions, or add some stuff, change this thing, add token, whatever you want to do, run a prompt, see the results. So you don't have to go to OpenChat GPT, right? Things like that. And I'm just waiting for the result to come back from Google Gemini. It came back. We showed you how many thinking tokens were there, how many output tokens were there, what the cost was. And if you go to the dashboard here, you will see exactly what we were doing, right? Less than a minute ago, just right now, we did some tagging here, again for visibility purposes, and the cost came about, right? Um, so this basically is the demo here. Um, and if you like to get this $50 coupon here, I'm going to put the coupon in the chat window so it doesn't go to public. You can add this coupon in here, go to settings, go to billing, go to credit, and add that coupon here and apply. You'll see your credit balance go to 0 to 50. What it allows you to is to play with our models. We have a couple of models like Cloud Gemma and Qwen 3.5, which is actually good enough for a lot of purposes, honestly speaking. So if you're building your applications, yes, you can use these models. It uses $50. And in the playground, when you say Cloud Idea, it shows you two of our models, and you can do all of that stuff. You can actually do evaluations with our models and so on and so forth. You can have Gemini, and then we will route to our model if you have selected the right option, and then you'll see the results with that as well. All right, so this is sort of the end of this webinar. If there are any questions, I'm happy to answer. You can also connect with me. This is some of the links here, and happy to chat more. Yeah, it's just really okay. I see what the problem is. Give me a second here. This is going to only copy. I see. To everyone. Now you should get it. There you go. My pardon. I was just sending it to the wrong place. And let me also copy this thing. There you go. So the sign up link is also down there. Awesome. So if nothing else, you know how to connect with me. It was a pleasure to do this webinar. Thank you for joining, and have a great day. Thank you so much.